Alright, so here we are. Um, Instead of doing the presentation, I have decided to explain how the engine works with the 3D model. So this is a V6 configuration engine. It's mostly used in Fortuners and even in the F1 race cars, which are very famous. So it has 6 cylinders in a V configured manner. Um, I'll show them to you. So you can see the 3 cylinders on this side and the 3 cylinders on this side too. And if I rotate it, rotate the crankshaft, you can see the cylinders moving. So let me show you the other parts too. It's not just the crankshaft, but the camshaft also is present. So um, so let's study how the engine works. I'll hide this part for now. And here we have the engine. Um, you might have read in the PPT about the four main processes that happen when we can look at them. I can't show the explosions and the fuel burning here, but I'll try my best to explain it to you. So this is the input valve. The engine, the fuel comes from this valve. So right now, yeah, the exhaust valve has opened up. Wait a second. So this is the input. This is the input valve, and this is the exhaust valve. And now the input valve open. Okay. So in the but the first starts with the input valve opening up, and the fuel flows in. As the fuel flows in, it comes up, and the exhaust valve burns up. So basically, what happens is, let me start again. The first, the piston comes up. It's in the starting position. The input valves open up, and we have the fuel flowing in, and then slowly the fuel is then compressed in the compression side in the compression process. Here the work done by the other cylinders is used to push this piston upwards, with the help of which the air fuel mixture is compressed, and now the the fuel gets ignited, and once the fuel gets ignited, it starts the it pushes the ignition, creates a mini blast, which pushes the piston down, and that after that the exhaust valve open up, and the air fuel mixture just comes out from this. So that's what happens in the process. But there are a lot of other things are also happening aside from this, and that is the opening, the coming up, and the coming, like the valves opening up. um the movement of the piston is comparatively easier to achieve, but to synchronize that with the air fuel mixture going in is where the mechanical genius comes in. So what happens is, I haven't, due to time constraints, I'm not able to show the belt, but uh, these are the belt wheels and the belts connected around these parts. So what happens is, the crankshaft is direct. This is the crankshaft, and it's connected to the belt wheel, one belt wheel, which is again connected to the other belt wheel through a belt which is absent here. So I have connected the motion of them. So what happens is when this comes up, when the shaft move because of the belt wheels, even this moves, and this in turn is connected to the crankshaft, the camshaft. Now the camshaft causes the movement, and you can see the rocker pins in function here. So when this, so this is the way the camshaft works. In this way, when the cam comes in, when the cam comes up, it pushes the rocker arm downwards, pushing the piston downwards, pushing the spring downwards, which in turn pushes the valve downwards, opening the valve. So that's how the engine works. And uh, and some other parts of the engine are the oil pan, which catches the engine oil if it falls down and prevents the leakage. Also, we have the exhaust valve and the input valve, and these are the pipes carrying the fuel to the input valve, and this is the carburetor. As you might have noticed, the spark plug is missing here, but this is actually a petrol engine, and this is the air filter. So that's how an engine works. And there are many other configurations of the engine also. Um, for example, in our day-to-day cars, the most of the cars we see, they do not have the V configurated or V6 engine type. These are used in very costly cars, like the higher end cars, Benz on Mercedes Benz, BMW, and other cars. But the regular cars that we see on road are three cylinder engines or four cylinder engines. Three cylinder engines are used mostly for petrol cars, and four cylinder engines are used mostly for diesel cars. But there are some cases where petrol vehicles also have four cylinders. And coming to some other important things is the differences between petrol cylinder and diesel cylinder. I haven't mentioned some parts, some things in the PPT. I'd like to say that first of all, uh, we all think that the diesel cylinder is more efficient than the petrol cylinder, but it's actually quite contrary. The diesel cylinder is actually more efficient than the petrol cylinder because of the compression ratio. Um, the thing is, in diesel cylinder, uh, the vibrations are comparatively lesser, because of which we can have a much higher compression ratio, unlike the petrol cylinder. So what we do is we go for almost double around 20 compression ratio in a diesel cylinder is around 20, which in turn increases the efficiency of the engine. But in the petrol engine, we can't go higher than 10 due because the vibrations increase, and the engine might get damaged, or the life might increase, or there might be a lot of noise. So instead, we go for a lesser compression ratio in the petrol engine. Um, one 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 vehicle that does not follow this is the recent Mahindra petrol engines, which have a comparatively higher compression ratio in their petrol vehicles. Um, I'm not. This has caused the sound coming out of the vehicle to increase, but it has also in some ways helped the engine become very sturdy and very strong, and it has made the Mahindra engines very unique. And if people are buying that, it shows that it's working pretty well, buying the vehicle. So that's all I have to present in this video. Thank you.